We are going to be going through the first part of Chapter 9 that deals with creating private classes and public classes. We're also going to cover how to create a class that has private fields and public fields, so it has both. And for our learning outcomes, this list of outcomes is for the entire chapter, and what we are going to be covering today are the first 7. Okay, and the reason I have split this into 2 separate weeks or 2 separate sessions is I want you to fully understand uh, how to create a class and what the difference is between public fields and private fields. Okay, and I want you to just focus on that. And then next week, we will add on to what you know. And I'm going to go ahead and hide that. So basically what a class is it is a type of blueprint that really describes the data that you're going to store, how that data can be accessed by programs, how the data will be manipulated or changed, and what data should be hidden. A class object is a variable that we create to store class data. And a class object is one instance of a class. And because an object is an instance of the class, we say that when an object is created, the class is instantiated. So if someone says the class has been instantiated, what they are saying is that they created a class object. To define and use a class, you will begin with an access modifier. If you omit this, it will use private. Private is the default. And the other modifier we are going to be looking at this week is public. Okay, and public classes can be accessed by anyone outside of the class. And it also affects how the class can be inherited. And inheritance is not something that we cover in this class, but inheritance is kind of a cool object-oriented concept where you can take a initial class and you can create a new class from it that reuses everything that's in this base or initial class. So it's kind of a cool way to reuse the variables and the methods that are already in a class. So we basically can pull them into our new one and expand on that. Okay? And we'll be covering that in the next course in this sequence. So access modifiers not only affect where this class is known, they also affect how it can be inherited by a new class. After the access modifier, we have a keyword class, and then we have the name of the class. And then we've got our curly braces. Anything between the curly braces becomes part of the class. And so we start with the class fields, and the fields are just the variables. Properties are a special type of field or variable that we're going to learn about next week. I want you guys to thoroughly understand public and private fields before we move on to properties. Constructors are designed to initialize the fields in the class. So we basically create them to give our fields starting values. Methods are little routines that can retrieve the fields or properties. They can put data into the fields or properties, or anything else that you would want to do with your fields and properties. You can do this with methods. And we talked about the difference between private and public when it comes to creating the class itself. But for the fields, we can create private class fields or public. It's a little bit more complicated when we create private class fields. So we're going to talk about that first. And remember, a field is just a variable that is storing data. By default, the access method on a field is private. A lot of developers or programmers will actually put the keyword private in, even though it's a default, just for readability purposes. And private access of fields restricts the methods that can access those fields directly. So if you have a private class field, only class methods can access the data, which means that only class methods can put data into the field, can change the data that is in the field, or retrieve the data that is in the field. Okay. Any method outside of the class does not have direct access to the field. And this is done to help protect data. Okay? Because if you are only letting class methods interact with the fields, you have total control over the type of data that is going into your fields. It is best practice to name private fields beginning with an underscore and to capitalize the first letter of the field name. And that is the convention that we will be following. And so this little example is a club class, and you can see there is no access modifier there, which means it is private. And each of the fields is also private, which means that if I have a main method, and if you remember, our main method is in a class that defaults to the name of program. So it's in a different class. So if we wanted to put data into these fields or retrieve the data from the fields, we would have to use class methods, okay? Because our main method cannot directly access these fields because they're private. We are going to take a look at class methods next. So a method can contain one or more statements that are executed as a single unit. A method may or may not return data, and a method may or may not have parameters. So you can have no parameters or 1, 2, 3, 4, depending on how many you need. If you are dealing with private fields, the class methods that you are going to create to put data into the field and to retrieve data from the field are called set and get methods. And so when you have private fields, you are going to need to create set and get methods for every private field. Okay? And the syntax to create a class method is you will have an access modifier. For set and get methods, this needs to be public, or your class will not be usable from by methods that are in other classes. So you have to make it public. Then you'll have a return data type, you'll have the name of the method, and you'll have your parameter list. And again, this can be empty. And if it's empty, you still need to have the parentheses. That is required. Then you'll have an opening and a closing curly brace, and in between are going to be the statements that you need executed. So I'm going to show you what a typical get and set method looks like. And so if we talk about set methods, these are designed to put data into the private field. So the return data type is going to be void. It has to be public. And then we use the word set at the beginning, and then a convention that is followed is to take the field name, without the underscore, and put that after set. Okay, so we've got set first name. The field name is underscore first name. Okay, and then because it's a set method, we need to pass it a string because first name is a string. So in our parameter list, we have string. I'm going to call the data first, and then I simply take first and place it into underscore first name. And that is what a set method does. And then you'll notice that I have one down here for ID. So it is called set ID. ID is an integer, so it is being passed an integer that I am referring to as identification. I take identification and I put it into underscore ID. Okay, so those are set methods. You have to have a separate set method for each of your private fields. To retrieve the data from the private field, you need to use a get method. So a get method has no parameters, but it is going to return the data type of the field. And so we've got get first name, and it's the same naming conventions that we use for the set method. We use get followed by the name of the field without the underscore. So we've got get first name is a string. So when we return underscore first name, we are returning a string, and that is why our return data type is a string. For ID, we're using get followed by the private field name, which is ID without the underscore. It is a get method, so we have no parameters. We are simply going to return ID, and ID is an integer, so our return data type is int. All get and set methods should have an access modifier of public. And here is get last name and set last name. And so you can see that they're pretty much set up the same way that first name was. So a few key points that you need to remember is that class methods have direct access to class fields. And it does not matter if the fields are private or public, the class methods can access them. And the fields do not need to be passed as parameters. Okay? When you have an object that calls a class method, and I will show you how that works in a minute. When you have an object, class object that calls the method, then the method is going to be able to access the fields and modify them or retrieve them. When a class field is private, the only way other classes can retrieve the data is through a get method. And the purpose of the get method is simply to retrieve data. We don't code it to do anything else. When a class field is private, a set method is used to place the data into the fields. Those set methods need to be public so other classes can change the values that are stored in the class. So we've talked about the get and set methods. And in addition to those methods, a class will have at least one constructor. The constructor is executed when a class object is instantiated. So when you key, and I will enter a little example here. So when you key club, which is our class, member, which is an object, and you set that equal to new club, we are instantiating the class and creating the member object. When you use new club, it's going to run through a default constructor. And it's the job of the default constructor to initialize numeric fields to 0. And then if you don't code a constructor, C# will make one for you. And for strings, C# will set those to none, or null, excuse me, null. A lot of developers choose to create their own default constructor where they have a little bit more control over what the initial values are set to. Oop. Okay, so constructors are used to initialize class fields, and they are automatically called when a class object is created. If you do not create your own, C# will generate one. And a couple things that you need to know, because you guys are going to be creating your own, is that a constructor, a name has to be the same as the class name. Constructors are almost always public, because if you make them private or protected, a program that is not part of your class will not be able to create class objects. Okay, so they are almost always public. A constructor does not ever return values. Its sole purpose is to initialize fields. In the default constructor, there are no parameters and there is no data returned. And so for all constructors, we do not have to identify a return data type because there is no return data type. For the constructors, we do have to enter a access modifier, and it should be public. Then we do the class name. There are, in a default constructor, where you are planning on initializing to zeros, or if it's a string, you might choose to initialize to string.empty instead of null. So for a default constructor, there are no parameters passed. Okay, so your parameter list is going to be empty. You have an opening and a closing curly brace, and then you have each field listed. You set it equal to either 0. If it's a string, you could set it equal to null. Most of the time, people will choose string.empty, okay, but you get all of those fields initialized. Now, you can have more than one constructor. And you can only have one default constructor, okay, that has no parameters. But the other types of constructors do have parameters. They will still not have a return data type. Okay, so typically you have two constructors. You have one that accepts parameters, and you use those parameters to assign data to each of your fields. So when you create a class object and you do something like this, instead of keeping that empty, which is going to go through the default constructor, you actually pass values. Okay, and so this will run through a parameterized constructor. Okay, a parameterized constructor is set up to accept data. Okay, and the order that you put the data in is kind of important. So you will have a data type and you'll give it a variable name. You'll have another data type, variable name. You'll do that for every single field. And because you're providing the data types, the order that you put this in matters. So here I've got 10, which is for ID. So my data type would be int, and I probably put ID here for the name. Then I've got first name, so that's a string. I'd probably put first or first name here. And then I've got last name, which is a string. So I'd do string and I'd do last name or last. And then here is where I would take each of those variables and assign it to specific fields. So in object-oriented programming, we can have two constructors with the same name because parameterized constructor has to have the name of the class, just like a default constructor has the name of the class. And what C# does is it actually looks at the data that you are passing, and it recognizes that a constructor that has data passed is different from a constructor that has no data being passed. Okay. And in object-oriented programming, we do this a lot. We have the exact same method name, but what we are passing in the parameter list is different. Okay. And C# allows that. It is called polymorphism. And polymorphism is an object-oriented concept. So I do have a couple examples of club constructors. The first one is the one that is initializing to numbers to 0, and any strings are initialized to string.empty, which is a very common way of initializing a string. The second one is a parameterized constructor. So I am receiving data, okay, and the data that they are passing needs to be in the same order that I am receiving it. So it lines everything up by position. So 10 is going to come in as ID, Fred is going to come in as first, Flintstone is going to come in as last. Okay, and then you can see I'm taking ID, assigning it to ID, first is being assigned to first name, last is being assigned to last name. Now, one important thing to remember with constructors is that if you create a parameterized constructor like this, C# will not generate the default constructor. And that means that you also have to generate or create the default constructor yourself. So if you do this, you also must create this default constructor. So the minute you code a parameterized constructor, go ahead and code up a default constructor because you will need it and C# is not going to create it for you. In object-oriented programming, we have an operator called this, and we use it to differentiate between the object that we are working with and parameters or variables that have passed to the method that we are in. And you might think, well, why in the world do we need to use this? And it is mainly because of a situation like this example. So here is another class called student. In this case, I have public fields, and the convention for naming public fields is to capitalize the first letter. So I got ID, name, subject, and age. Okay, and then I've got a parameterized constructor. So in my argument list or parameter list, you can see that I have the same exact name as I do for my class fields. And that is a situation where you need to use the keyword this. Because if we just did ID equals ID, C# has no idea what ID we're talking about. Is it this one? Is it this one? C# does not know. Okay, so when you put this dot in front of ID, it knows we are working with the class field. Okay, and that is why you would need to use the keyword this. And you can see we have it in front of name, subject, and age, identifying these fields as part of the class. And so when we set it equal to name, equal to subject, equal to age, it knows that we're talking about these values that are being passed in. Okay, and using the keyword this avoids any kind of confusion on C#'s part. And if you don't do this, I guarantee C# will get confused and you're going to have something called a naming collision, where it's either going to flag it as an error or it's going to put the data in the wrong spot. It's going to give you problems. So in a situation where you think that C# may get confused, you always want to put the keyword this in front of the class fields. The null keyword. So null is a default value for reference types, and it basically just represents an empty reference, okay? Something that has nothing in it. You cannot assign null to value types. So we cannot assign null to all of the primitive data types, which include Boolean, character, integer, short, long, float, double. Okay? Those are all primitive values, and you cannot assign null to them. So what can you assign null to? Well, you could assign it to an array. You can assign it to an object. You can assign it to a string, because those are all reference types. The problem with assigning a value of null is that a null object cannot call class methods, and a null object cannot access fields. Okay? If a null object accesses data or methods, your program is going to compile, but it won't run. You are going to get an exception, specifically a null reference exception, because you're trying to access either public fields or class methods with an object that is null. One reason that developers create their own default constructor is because the one that C# will generate initializes the reference types, which are strings, lists, objects. It initializes them to null. And if you create your own default constructor, you have control over what you initialize those to. And remember, anytime that you have a parameterized constructor, you have to also create your own default constructor. So we talked a little bit already about instantiating a class, and that a class in and of itself is just a template, and it does not take up space in memory. So if I have this, okay, basically I'm letting C# know that I do have the intention of creating the member object, but it is not created yet. Because in order to create it, we have to instantiate it by setting it equal to new and club. Setting it equal to new and club instantiates the class and actually creates the member, because it goes through the constructor that initializes all of the fields that are part of that class. And when you initialize those fields, you do have them in memory. And typically there are two syntax examples or ways that we initialize our objects. First method is probably the most popular, where you have it run through the default constructor. The second method involves passing data when you actually create the class object. So we're creating a new member object here, and instead of using the default constructor, we are using the parameterized one that actually accepts these values and places the values into the fields. In order to use public methods in a class, you have to create a class object. And then to access the method, we use the object name dot method name, and we always include the left and right parenthesis. Okay? And if the method needs data in order to run, we put the data in the parentheses. Otherwise, we just enter both parentheses and keep it empty. You have to have the parentheses, but you don't have to have a value inside them. If we want to access a public field, so this is a field in a class with the keyword public in front of it, then we use the object name dot field name. And if it is a public field, we can print using the object name dot field name, and we can also assign a value to it. And we could have an equal sign, we can have a value, and we have direct access to it. So we will be looking at more at the public fields in a minute. But first, we are going to take a look at a couple examples that are still using private fields. So here we are creating a new object called new member. I can see that we are using our parameterized constructor because we're passing data. And club has 3 private fields. So if the club class does not have a print method and we want to retrieve the values and print them, what we have to do is use the class object and a dot, and then we actually have to use the get method. Okay, and so it will be get ID to retrieve the ID. You'll notice that we have a left and right parenthesis with nothing in it. Those parentheses are required. So it is the object name dot get ID, left and right parenthesis. It will retrieve the 10, the number 10. Okay, and so it'll say ID equals 10. Okay, then for name, it's very similar. We take our new member object and we call get first name. So what it's going to display here is Frida. So we'll have name equals Frida, and then we have a space, and here it is going to retrieve last name. So we'll have name equals Frida space Flanders. The other way of creating an object is to use the default constructor. So when you use the default constructor, that means you are going to have to use the set methods to put data into the fields. So here we've used our default constructor, and that's initializing to 0 and string.empty. And then to put something into an ID, we use the class object member dot, and then we call the set method, which is set ID. In parentheses, we can either hard code a value and pass that along, or we could actually use a variable that is storing a number in this case. For first name, we take our object member dot and we call set first name. And then you can see I'm sending it a string, Taylor, for the first name. And then I'm doing something similar for last name. And we are going to take a look at the coding examples because they are full programs. And sometimes it is helpful to see everything in context. We have 2 examples here. The first one is the full example from the chapter. And so you can see we have 3 private fields. Here we've got the 2 constructors, the default and the parameterized constructor. And then we have get and set methods for each of the private fields. Okay, and that is pretty much all we have in this class. In the main program or the main method, we are creating 2 class objects. The first one is created using the parameterized constructor, and then we are printing using a write line along with the get methods to retrieve the data. The second object is created using the default constructor, and then to put data into the fields, we are using the set methods. And then the write line is pretty identical to the first one because we are using the get methods to retrieve the data. The second example is similar to what you guys are going to need to do in your lab assignment. The class itself is identical to the first example, nothing different there. The only difference really is that under the get and set methods, I've created a print method. Okay, so this will allow anyone who uses this class to simply take the class object and call the print method. and then this is what we'll print out. So in this main method, we start out creating an object with the default constructor. We use these set methods to put data in, and here we are still retrieving the data in a write line. We're not calling that method yet. For the second object that we create, we are using the constructor that accepts parameters. And then we are calling the print method. So we are taking the object and we are invoking print or calling print using that object. We have a third object that we're creating. Okay, and this one is also using the default constructor. But instead of using the set methods in main, we are going to use an add data static method that is below main. And because add data is not part of our club class, we do not, prefix this with an object. But add data is going to need access to those fields that are in member 3. So what we do is we're passing the class object. So we're calling add data, we're passing the member 3 class object. Okay, and add data is going to fill in all the data. And then when it returns, we're going to call the print method that is part of the club class. So let's take a look at add data, because this is something that will be new to you. We are passing a class object. Class objects are passed call by reference, which means that any changes that we make to the object, those changes are going to be retained. Okay, so it's not passing a copy, it's giving us access to the fields that are part of the object. So the reason we did this method is basically so we can do some validation of the data. So we've got please enter the member ID. We read it in as a string and then declare an integer ID. And we do a little validation loop, basically to ensure that they are entering an integer. Okay, so as long as they have not entered an integer, then we tell them to enter a whole number for the ID, and we're reading it into the string. Okay, once this is able to successfully convert the string ID into an integer, it will store the value in new ID. So when it pops out of this while loop, new ID has a valid integer in it. And that is when we call the set ID method. So we use member, which is our object, to call set ID, and we pass it the validated new ID. Okay, and we are going to do something similar for first and last name. So we ask, enter your first name. We read it in as a string, and you'll notice that we are making it nullable. So it is possible for them not to enter anything, right? Just to press enter. And so we do need to validate that they have entered something. And so we are going to use two different validation methods, is null or empty, and is null or white space. So if either one of these returns true, that means that they did not enter valid data. So we prompt them to enter a valid first name and we read it in. Okay, and we're going to stay in this loop until they have entered something that is not null, not a space, or not empty. Those are the three things we're checking for. So by the time it comes down here, we know that the first name is valid. And so we take our member object and we invoke set first name and we pass it that first variable that we have validated. And then we basically do the exact same thing for last name. Okay, so it's almost a duplication of the code. And then we return. Okay, so that is how we're filling in member three. And then once it's filled in, we can call the club class print method. We are going to take a little closer look at public class fields. These are easier to code. And mainly because you don't have to create set and get methods for them, but they are not as secure because when you make a field public, any program that wants to access those fields can. They are not as protected as private. Okay, so you don't have as much control over the data that is being stored. If you create these public fields, you still need constructors. Okay? You'll still have a default constructor, and you may also choose to create a parameterized constructor, but you don't need any of the set or get methods. So with public fields, if I use the default constructor, then you may think, oh, well, how do you get the data in then if you don't have a set method? Well, I can directly access ID. So all I do is I take my object member, a dot, and then the field. And I can use an assignment statement to put data into that public field. And if I want to print, I can simply use member.id to retrieve the data. Okay, so we are using assignment statements here for ID, first name, and last name because they are all public. And then here's an example of how I would retrieve that data for printing. And so you can see we do not need to call a get method. We just need to put the object dot and then the field that we want to print. Okay, and we're going to look at a programming example now that actually it'll show you the full program for the example that we were just looking at. And there's also a second program that is similar to what you guys are going to be doing in the lab exercise. So this is the full programming example from the chapter. And so you can see, if you're not going to code a parameterized constructor, then you don't need to code a default constructor, and you can just use the one that C# generates. So you'll notice that the class becomes quite small. I mean, all you have to do is define your fields, okay? And they're all public. Then in the main method, when you create a object, it's going to go through that default constructor that C# generates where numbers are set to 0 and any of our reference values are set to null. And that includes strings. Then if you want to put data in to the different fields, it's just the object dot and the field name. And you can assign hard-coded values. You can also read data in from the console and put it into, those fields. So the only difference here between what we've been doing with variables and fields is that, if it's part of a class, we have to prefix the field with the object and a dot. Otherwise, all the different ways that we've been putting data into our variables, we can do with public fields. So we assign values to those fields. If we want to print them, it's just the object dot and then the field name. Okay, and so I've got a couple examples that are using that with some sample output. And this next example is similar to what you guys are going to do for the lab, the second lab exercise. And so the purpose of this one, this example, and also that second exercise is so you guys can become familiar with public fields and, recognize how they're different from private. So this example obviously includes the fields, and we also have a default constructor, a parameterized constructor, and a print method. In addition to that, the example includes a static method that is below main that accepts a class object as a parameter. It happens to be an add method, so we will be prompting for data, validating the data, and then we can directly assign the data to our public class field without using a set method. Okay, so we'll take a look. So we have our class club. We still have the same 3 fields, but now they're public. And here is our default constructor, where we've got the ID, which is a number set to 0. Our 2 string fields are set to string empty. Here's our parameterized constructor, where we are receiving the ID, the first name, and the last name, and we simply assign those values. And then we have our print method that is accessing those fields and printing them out. In our main method, we are creating 3 different objects. The first object is going to use our add data method. So we create an object using the default constructor. It's called member1. And then we have this static add data method, and we are passing it our class object member1. And remember, class objects are passed, call by reference. So when we make changes to the fields that are stored in member1, those changes are going to be retained. So let's go down and take a look at add data. So add data is receiving a club object. So we have to use the keyword club here for the data type, followed by whatever we want to call the object when we are working in this method. Return type is void because the changes that we are going to make to the fields that are stored in member, those changes are going to be permanent. So here we are asking them to enter the ID. We are reading it into a string variable so that we can validate it. We create an integer variable, and then we have our error handling loop where we are using int.tryparse. And so it's going to check that string ID. It's going to try to convert it into an integer and store it in new ID. And if it can do that, awesome, we get out of the loop. If it can't do that, then we have a little message that displays and they have to type in the ID again. So we're going to stay in this loop until it can do the conversion and store the value in new ID. Once it does that, we're going to be out of the loop, and we just do a direct assignment statement. We've got our object member dot ID, which is our private or public field. We set that equal to new ID. For the next 2, first name and last name, the procedures are going to be extremely similar, almost identical. So we prompt to enter the first name. we read that into a nullable value called first. And then we are checking first to see if it's null or empty, or if it is null or white space. And if either one of those is true, we have a problem, and we prompt them to enter a valid first name. And then we read it in again. So we're going to stay in this loop until they actually give us a first name. And then we assign that first name to our object dot our public field, which is first name. And then last name basically does the same thing. And then we return up to main. So we return to where it was called. And then we proceed to the next command, which is to take our object and call the print method that is part of the club class. So basically, it's going to go up here. It's going to print out the value. For object number 2, we are creating an object named member2. And we are again using the default constructor. And here we are just directly assigning values using the object member2 dot, and then we're using our field name. And then we are choosing to do our own write line statement instead of calling the print method. And so to access those values, we are using our object dot and then the field name. And again, we can do this because these are public fields. The third object that we are creating, member3, we are using the parameterized constructor. So we are passing the values to member3. And then we are using the club print method to print them out. Okay, and you can see some sample output down here. So some key points to remember. Public fields do not need get methods because you can directly access them using the object name, a dot, and the field name. Public fields do not need set methods because the data can be directly placed into the fields using the object name, a dot, and the field name. Public fields do not begin with an underscore. They begin with a capital letter. The way that we use constructors and methods doesn't really change if the fields are public versus private. Constructors are still automatically called when a class object is created, and you still have to call methods using the object, a dot, and the method name. So that does not change. The main difference is that the public fields can be accessed from outside the class and the private fields cannot. And up to this point, we have pretty much looked at examples where all the fields were private, where all the fields were public. And we are going to take a look at a little more complicated example where the fields can be a mixture of private and public. So this is a kind of lengthy example, and rather than creating single objects, what we are going to do is create an array of objects. And creating an array of objects is just like creating an array of anything else. Okay, the class name becomes our data type. And then we have brackets. We have to have an object. Okay, and so we give the array object a name, set that equal to new, followed by the class, and then the size. Now, what is interesting, or you might think it's strange, is that when you do this, C# does not run it through the constructor. Okay, you actually end up having to do that manually. What C# does is it assigns your your array object, a value of null. And we know that null is a problem because we can't call class methods and we can't access class fields. So after you create an array of class objects, you need to iterate through or loop through and access each element because each element in that array is storing an object. Okay, so you access each element and you assign it to new, followed by the class. Okay, and that calls the constructor. And then the constructor is going to put the zeros and the nulls into your strings, the zeros into your numbers, or if you've created your own constructor, then it's going to do, whatever you decided. Zeros for numbers, string.empty for strings, and whatnot. So this will go through every single object in that array, and it will basically run the object through the constructor. In addition to having the class and having our program class where our main method is, we are going to have a static menu method below main, and we are also going to have a static add method that is below main. And the menu method is going to display add or print or quit. Those are going to be their options, kind of keeping it simple. Because we are allowing them to determine the size of the array, they could make the array 200 big, okay? And they might not want to add all the data at one time. So we do need to keep track of how many objects have been added. Okay, so we're going to have a counter. So looking at our creature class, we're going to take a look at that first because that has public and private fields. So we have 3 public fields in this class: ID, name, and type. And then we also have 3 private fields. We have 2 Boolean, and then we have a list. Okay, and because we have a list, when we initialize this, we have to actually instantiate our list using new list. Okay, so the default constructor, you'll notice that any numeric data, any numeric field has a value of 0. Our strings are set to string empty. Our Booleans are initialized to false. And then for powers, which is a string list, we actually set that equal to new list. Right? And you have to do that or you are going to get runtime errors. The parameterized constructor is accepting data that has been passed when a creature object is created. Okay, and so you can see I've kind of used a little shortened version of variable names here. But then you'll notice at the end here, list string is my data type. Okay. And so this is basically a filled in list, and we are calling it POW. Okay, so I assign all of these values that have been passed, including POW, because you can assign one list to another. Okay, and so that is the parameterized constructor. I only need get and set methods for the private fields. So those are the only fields I create them for. Okay, so you can see here is get danger status. So it's returning it, and that is a bool, return data type. Get human status, it is returning that. we've got a bool, return data type, and then we've got get powers. So it's going to return powers, and the data type is list string. Okay, so those are all get methods. And then I've got my set methods. So these are going to put data into those fields. So the return type for all the set methods is void. And I've got set danger status. The argument that is being passed is bool for Boolean, and we're going to call it danger. And we just set danger to is dangerous. We kind of do something similar for set human status. We are bringing in a Boolean parameter called human. We set human to is human. There is no data being returned, so the return type is void. For powers, basically do the same thing. The parameter list is going to have a data type of list string, and we're going to call it pow. And then we just assign pow to powers. We are not returning anything, so our data type is void. This creature class also has its own print method. Okay, so you can see that the creature number is pretty straightforward. We are basically going to assign the IDs or the counter to the ID, and the counter starts at 0. So we're going to add 1 to display that. Then we're going to retrieve the name, which is a public field. We're going to retrieve the type, which is a public field. And then we retrieve is dangerous and human is human, which are private fields. And you can see how useful these conventions of underscores versus just starting with the capital letter. You can see how useful that is because you can look at this code and you can see, oh, yep, that's a private field and that's a private field. For powers, because the powers are stored in a list, we actually have to loop through the list. But we really only need to do that if the creature actually does have at least one power. So we are using powers.count to see if it's greater than 0. Because if it is, then we got powers that we need to display. So we've got powers include, and then we have a little loop that is going to iterate through our power list and print out each of the powers. So you can see the condition for the loop is I less than powers.count. Okay, and then to retrieve the power, we index in with I. Okay, and that's how we are going to get each of the powers listed out. Now you'll notice that I'm using right instead of right line, and I have a little space here after the power is printed. Okay, and so that's just going to display those powers horizontally, within the line. So that is our class. And before we get into how the main method works, we're going to come down here and we're going to take a look at menu and add creature. So we'll take a look at menu first. So for the menu method, we are not passing any data, but we are going to return the character that they enter. And we're going to validate it. So please make a selection from the menu. Their choices are A, P, and Q. We are going to read that in as a string. We are declaring a character variable called choice. And then we're first going to make sure that they entered a valid character. Okay, and if they didn't, it's going to, prompt them to enter an A, P, or Q, read it in, and then it's going to check it again. Once they enter a valid character, that character gets stored in choice. And then we're going to see if it is not equal to an A. So this is the error condition. If it's not equal to an A and it's not equal to a P and it's not equal to a Q, if it's not any of those, we have a problem. Okay, so if any of these is true, okay, then it's valid. Okay, or actually, if it's false, right? So if it's not equal to an A, if it does have an A in there, it's going to be false. Okay, so we're only going to stay in this loop if let's say they type a Z. Okay, so, well, Z doesn't equal A, that's true. Z doesn't equal P, that's true. Z doesn't equal Q, that's true. So then it displays this message. So if they do type one of the required letters, then we're going to be out of the loop. And you can see that we are returning it to the main method. We are converting it to uppercase, and we are returning it. And the reason I am returning it in uppercase is so that when I use my switch, I only have to look for an uppercase letter. So let's take a look at the kind of lengthy add creature. So when we call add creature, we are going to go ahead and pass it the entire array. We're also going to pass a reference to the counter that is keeping track of how many creatures we've entered. And so when we come in here, we can actually use this counter to index into the my creature array. Okay, because this is going to represent the next empty object that we need to add data to. For the myCreature.id, I am just taking whatever numbers in the creature counter and assigning it. ID is a public field, so I can use a direct assignment statement. So what's different about this is that this myCreature object is an array. So we have to index in. Okay, and so the first time we do this, creature counter is going to be a 0. So we index in to position 0. And then basically what we're doing is we're taking a 0 and storing it there as the ID. Then we are going to fill in the type of creature, and type is also a public field. So we prompt to enter the type of creature. We create kind of a temporary string I'm calling temp value, and we've made it nullable. And then what we're doing is we are checking to make sure that there's a valid value in temp value. So we're making sure that it is not null or empty, and it is not null or white space. If it is either of those things, then they have to type the value again, and we're going to stay in this loop. Once they have a valid value, then we come down here. We use the creature counter to index into the my creature array, and then we use dot type because type is a public field, and we can directly assign temp value to it. Then we basically do the same exact procedure for the name of the creature, okay, because that is a string. We ask them to enter the name. We've already declared temp value, so we can just do a console.readline and retrieve the value for name. Then we have our validation loop where we're making sure that temp value, which is a string, it isn't null or empty, and it is not null or white space. Okay, and if it is not null or empty and it's not null or white space, we get out of the loop. You can see that we are indexing into my creature with the creature counter. We've got dot name because name is a public field, and then we assign temp value to it. Okay, so pretty straightforward with the public fields. So with the private fields, we're going to have to prompt for the data. We're going to have to validate the data. And then we are also going to have to use the set methods to put the data into the field. So the first value is Boolean. So we ask, is the creature dangerous? Y for yes, N for no. We are reading in the value into temp value, which is a string. And then we declare character temp, which is going to actually store the validated character. So here we have our validation loop, and really the only thing that we are going to check is that it can actually convert what they entered in temp value into a character. And if they can do the conversion, that character gets stored in temp. And if they can't do the conversion, we see the prompt that the value has to be a Y or an N, and we read it in. Okay. And so why am I not checking for Y or N? The only thing that really matters is the Y. I mean, I could have changed this, Y for yes, any key for no. That's really the only thing that matters. And so after we validate that it's a valid character, I am checking the lowercase version of temp to see if it is a Y. Okay? And if that's true, then I am indexing in to my creature, and it is invoking set danger status, and we're just passing true. And if it is not a Y, if it is anything else, then we index into my creature and we are calling the set danger status method and passing it false. Okay, so that is how we are handling Boolean. And we are doing the exact same thing for the is human Boolean. Okay, so we're asking if the creatures all are part human, Y or N, reading the value in, and really we're primarily concerned that they can take that string and convert it into a character. And as long as they can do that, when we pop out of the validation loop, all we're really concerned with is whether they entered a Y or not. So we convert it to lowercase, we check. If it's a Y, we are going to call set human status, pass true. And if it is anything other than a Y, we call set human status and pass false. So what is a little tricky is the list. So we have to first of all know if the creature has powers. So we prompt yes or no. Read the value in. Again, we are doing the validation to see if they entered a character. And if they did, we store it in temp. And if they did not, then they end up seeing the right line. They have to type it again, yada, yada. Okay. So by the time they get out of this loop, we do have an if statement because we need to check to see if they entered a Y. That is what we are concerned with. Okay, so we say if char.toLower temp is equal to Y, then we are going to do all of this. Okay, and so what are we doing? Well, we are creating a new list. Okay, and then we have a variable called power entered, and it's a string, and we basically are setting it to nothing. And then we've got another loop where it's checking power entered to make sure they didn't type quit. So we're going to stay in this loop until they indicate that they are done entering the powers, in which case they are going to type quit. So we've got enter the superpower or quit to end. So we read in power entered. Okay, then we do need to check to make sure that it is not null or empty. So if what they entered is null or empty, then we tell them it can't be spaces, null or empty. They have to enter it again. By the time they fall out of that loop, we do need to check to see if they type quit, because if they did, then we need to continue, and it'll pop back up here where we're checking to see and make sure they haven't keyed quit. But as long as they've entered a valid power, we take our powers list and we call add, and then we pass the power that they entered. Okay? And so we are going to stay in this little loop where they enter the power or the word quit. We read it in, we make sure that it's not null, empty, or space, make sure it's not quit, and then we add it. So eventually they are going to type quit, and then we are going to get out of the loop and we'll be on this line. And so this is where we are going to call set powers, and we're going to pass it that new powers list that we just created. So we index into our my creature array of objects. We call set powers and we pass it the new list of powers. Okay, so this is everything that we do if they answered yes at the prompt that this creature does indeed have powers. Okay, and so once we are done with that, we add one to our creature counter and we return to main. So let's take a look at what main does. So the first thing that main does is it asks how many creatures you want to enter. We read it in as a string. We declare a integer called count. And then we just basically validate that they have actually entered an integer. And if they did enter an integer, okay, what's going to happen is it's going to store it in count. And then we want to make sure that it is not less than 0, because that is a problem, right? We can't very well create an array of objects with a 0 or a negative value. Okay, so we are just validating that yes, they have an integer, and yes, that it is bigger than 0. Okay. Then once we get done with the validation, we are creating the creature counter, and that is going to be used to keep track of how many objects we've entered or added. Okay, and then we create the array of creature objects. So creatures are class. We do the brackets to indicate array. We give that array a name, set it equal to a new creature, and then in brackets, we indicate the size. And as I mentioned earlier, when you do this, C# sets this array of objects to null, does not run them through the constructor. And when you have an object that has a value of null, you can't call methods and you can't do anything with the fields. So our next step is going to be to iterate through the entire array of objects and basically instantiate each one of them. So how do we do that? We are using as our condition, I is less than count, starting it at 0, because arrays, the index begins at 0. And so we take our array of objects, index in, and we set that equal to new creature. This is going to call the default constructor, and that is going to initialize this first creature object to, actually it's going to do what I specified up here, okay, and it's going to run through this code. Okay, and so it does it for the first one. I increases by 1. It does it for the second, the third, the fourth. Yeah, however many I indicated that I wanted. Then it calls the menu method, which returns their validated choice. And I'm storing that in a variable called select, short for selection. And then the main part of the program is right here. So while they don't choose Q, we are going to um, look at their selection. If it's an A, we can add the creature. If it's a P, we're going to print. And honestly, it shouldn't be anything else because we validated this. So I do always include default, but if it ever displayed this default message, huge problem. Okay, we have got a huge issue in this program because it never ever should do that. Okay, so you'll notice below the switch, we call menu again and retrieve their next choice or selection. Okay, so let's take a little closer look at what we do if they do an A or a P. So if they do an A, first thing that we need to do is make sure they haven't entered all of the creatures yet. So we take the creature counter, which indicates where we're at. So if they said they wanted an array of 100 creatures, okay, we need to know if they've entered 100 or not. So as long as the count is greater than the creature counter, that means they haven't added all of their objects yet. Okay. And so we go ahead and call add creature. We pass the entire array of objects and we pass a reference to the creature counter, as we have to use that to index in to our array of objects. Now, what happens if they have maxed out? They've entered all their objects. Well, we're just going to display a message that they've reached the maximum. Okay. We're not actually going to, make them exit this loop because they can still print. Okay. So we just tell them they've reached the maximum and we display the menu again. If they choose a P to print, first of all, we need to check to make sure they've actually added an object because you can't print something that doesn't exist. So we make sure we check to see if the creature counter is 0, and if it is, we tell them they need to add a creature. Otherwise, if it's not 0, then we are going to loop through the array. I'm going to take a look at every creature they've entered, and we're going to call print. And so the condition here is I less than creature counter, because this creature counter is how many objects we've added. Okay, and then we use I to index into my creature, and we call the print method. So that, in a nutshell, is what this program is doing. And for your third exercise, you are going to create a class that is much smaller and much simpler than this one. You will have 2 public fields and 2 private fields.